Hello everyone. I just want to give you some hint on how to simplify the Boolean expression. First of all, why you would want to simplify the Boolean expression and what the expression considers as simplified. Well, because we want to use the Boolean expression to design logic gate, and each operator will have one gate. So to consider simplified as fewer operator as possible. For example, let me go through the first one. And to simplify this, what you use is based on the rules of the Boolean identity. We have so many rules. And then let me go through each of these rules a little bit. And so this one is easy. Identity rule multiplied by 1. And there's an OR form and the AND form. This null rule, and think about a realistic example. You understand these rules, and we use these identities and to simplify the Boolean expression. Okay, so and these are the names. Every step you have to say which you use. Okay, now let's go over the first one. For example, then you observe so that A, B, and B, C, and probably you see that this the units. We can use this things kind of like a multiplication, right? Distribution rule. So this units, so then you go first. Is A BC times B, and then BC again goes. That's distribution rule we used here. And now, then you put, say you want to reduce the number of the variables or number of ultimately not less operators. You can use the commutative rule. So you can move the B next to each other, move C next to each other. And so then in that 2B and B and C is nothing but just one C. So it's like a realistic situation. You say something's good, you say good twice, it's just once. Same as once, not like squares. Okay, and then that is commutative rule, and that's idempotent rule you apply. And this is just a B, and that is just a C. So then that's a B shrink together. So now you have BC again, BC again. Then you can still using idempotent rule, and this is just one of the BCs. And then of course you have one BCs and BA, and then idempotent rule. And then you go commutative rule. So like A times B, B times A, the AND operator is kind of like just a multiplication. So then you B put together, and then you use a distribution rule again, pull the B out in the front. So, and what you may not very familiar with this, but this is the exercise. You're the student, you learn this. You put this on the side and observe your expressions, see what you can use. So that's what I would do. So you put this identity on the side and look closely. So can reduce. See if this one is actually reduced to that. So to begin with, we have like 1, 2, 3, 4, 5, 6. Yeah, 5 operators. Now there are only 2 operators. So reduce. If you are to build this with gates, you have only need 2 gates. So I decided to give the hint for first question of every problem. So this is the second problem. I wanted you to get from the diagram to the Boolean expression. So the trick is realizing this is actually OR, and that is AND. So you go from the rightmost, okay, and then you put this OR first. So that OR, okay, and then OR has 2 sides. And one side obviously A, so that's A, right? So A, okay, and then A, and the other side here, you know what this one, and that's AND. So that one, this side is B and C. So there, so is this wire. So therefore, B and C. That's it. Easy, right? Well, actually, that was the number 2A as well as 2 B. Well, excuse me, an error had occurred. Just a moment. Actually, this was the answer for 3A and 2A. So 2A, I want you to do circuits, but actually it's this. And 3A, what is the expression? That is this. Then actually they are matching. So this is that, the answer. 3A, you get from this to that. 2A, you get this to this. Now, to compensate that, and let me work on another one. Well, that was 2A and 3A. That's this one. Now let me work on this 2C then. Find the circuits for this expression. So then you from the middle one, you find this one is an AND. You go to AND. So this AND is the first AND. Okay, that's the output. Okay, that's my star here. And then there will be two sides. One is this side, and one is the other side. So, right, so then you will have this side is a OR. So this is A or B, this side. And this side is A or C. So A or C. So this A or B, let's see, this input A, B. I'm sure you can draw much better than I do because I'm using a mouse to draw. So then this is the OR, A or B. The OR is shaped like this, and then you have that. So A or B. So then it's connected here. Okay, and this is A or C. So A or C. So then, first we get the OR together. That's the OR, curvy end. So A or C. So then A, of course, you have a connector A, and then this curve like jump over. Like in electrical engineering, if you know, that's this. The circuit jump over. A or C. So that's my answer. So that is the circuits for B, for C. So this is 2C. Well, I think I give you the hard one to you. I think you can have fun doing this third one or fourth one. And then if you still have a question, send me emails or put in a discussion. I hope you enjoy playing with this. Bye bye for now.